Okay, so if we went back and I'm going to put a simple problem up here where you can look at and tell what the answer is. But if I asked you to solve this linear equation, let's say it was x plus 3 equal 5, then you can easily look at this and tell me what the solution is. It's what? It's x equal 2, right? So this linear equation had how many solutions? Just one. So this has one solution. Okay? Now, if you look at this linear equation, how many variables do you see? How many variables do you see? One. There's just one variable. It's a variable x, right? And I guess I should have said how many distinct variables do you see? Because I don't want you to get confused with what we just did. And I asked you the question, how many variables do you see? You may say, well, I see two. There's one on the left side, one on the right side. So let's just say, how many distinct variables do you see? Just one. It's a variable x. But what if I asked you to solve this equation? Let's say you had x plus y equals 7. All right, it's an equation, right? Okay, I can solve that equation. You can have more than one solution, you're saying? Okay. So for example, if you say x is 2, then you're saying y would be something? Okay. So if x is 2, yeah, y would be 5 because 2 plus 5 is 7. Okay. So that would be a solution. Remember, a solution is a number that will make the equation a true statement. The left side would equal the right side. But what about if x is, let's say, 0? What's y? 0 plus 7 is 7. So far we have how many solutions? 2. We have 2 solutions. How many solutions do you think this equation has? What is a lot? 80? 72 of them? An infinite number, very good. It has an infinite number of solutions. I can plug in any number for x. Now, I've been using whole numbers. You could use decimals as well, right? You could use fractions as well. But when solving equations that have 2 variables, it's always a good idea to use integers. Integers. So I could have said, now this is a little bit hard for some of you, but think about it. If x is a negative 2, what is y? Negative 2 plus what number is 7? Very good, 9. So you can't have negative values for your variables. Now notice I use the word integer. Integer. Do you remember what integers are? So your integers are numbers like your whole numbers, 1, 2, 3, 4, and so on, right? No decimals, no fractions, just whole numbers. Are your natural numbers, meaning 0. And then the opposites of them, negative 1, negative 2, negative 3, and so on. So those are your integers. And so when we solve these equations, and these equations now have how many variables? 2. They have 2 variables. So you're going to end up with how many solutions? An infinite number. There's an infinite number of solutions. Okay? So whenever you solve an equation, you want to list the solutions. Well, is there any way you can list all these solutions like we're doing? No. So we're going to denote the solutions a different way. And the different way, the way you denote an infinite number of solutions is by graphing. So that's why you graph. So anytime you graph anything, you're graphing the solutions to that equation it represents. That's what you're doing. So let's look at this one right here. So instead of saying solve x plus y equals 7 like we did, it's now going to say graph x plus y equals 7. So let's go ahead and graph x plus y equals 7. Now, what kind of equations are we dealing with? Linear. That's all we're dealing with right now. Remember, your linear equations, the way we talked about in last class period, although there's a more formal definition of it, your linear equations, you're going to have the exponent of the variables being what number? Do you remember what we talked about? Your exponents have to be what number? 1. 1. X to the first, and this says y to the what? First. Okay, so that makes the linear equation. Okay, now you got to remember when graphing these linear equations, remember use the t-table? Use the t-table. So we use a t-table. And so when you use the t-table, you may remember this. The first column was represented by what variable? X. And the second column was represented by y. And so when we started talking about this, I said if x is 2, what's your y value? 5. And it was easy to determine that because you could look at this and say 2 plus 5 is what? 7. But if for some reason, and all of you should have seen that, and you probably did, but basically they're not always be that simple, right? So what you would then need to do is say this, all right, I'm letting x be 2, and so wherever we see the variable x, what do I substitute? 2. So I'm going to say 2 plus y equals 7, right? And now that looks like what we've been doing with day 1 last week. How to get y by itself? Is adding 2 or subtracting 2 going to help? Subtracting 2. So subtract 2 from both sides. Then combine like terms. 2 subtract 2 is 0. 0 plus y is y equal. 7 minus 2 is 5. So that's what we're going to be doing when we go through this. So if x is 2, what's my y value? 5. We said if x was 0, what do we get for the y value? 7. Because 0 plus 7 is 7. So that's another solution. Remember, all these are solutions. So far, I have how many solutions? 2. We also said this. We also said if x is negative 2, and some of you were able to very easily determine that the y value was 9, right? Because you said negative 2 plus what number is 7. So some of you have enough experience to look at this and say it's 9. All right, if you did not, then go ahead and do that substitution we did here. So you said negative 2 plus y equal what? 7. All right, so I got to get y by itself. Is adding 2 or subtracting 2 going to help? Adding 2. So you add 2 to both sides. Negative 2 plus 2 is 0. 0 plus y is y. 7 plus 2 is 9. All right, so that's what you would do. So far, how many solutions? 3. So at this point, if we start plotting those points in our coordinate plane, so go ahead and take out your grid. So we're going to graph x plus y equals 7. All right, so x plus y equals 7. So I might have to expand this on my end. You can see yours up here. All right. So our first solution was that x was 2 and y was what? 5. All right, do you remember how to plot points?
Yeah.
Okay. So when plotting points, you basically start at the origin. Remember that? So I want to plot the point 2, 5. So I'm going to just go ahead and write 2, 5 right here. Now remember, to label the point, you got to see how I have 2, 5 listed in a table? As a point, you got to put parentheses. You remember that? And so you would say parentheses, my first coordinate is your x coordinate, your second coordinate is your y coordinate. Remember, these are called an ordered pair. Remember that word? So basically an alphabetical order, ordered pair. So I put the x first, y first, and all of them. All right, now in both cases, they're both positive numbers, correct? They're both positive. So you start at the origin, you do x first. X is what kind of number? Positive. So I go 2 units to the right. If x was negative, I go 2 units to the left. Okay, so from the origin, go 2 units to the right. So I go 1, 2. Don't put a dot there. Just hover over that little area. My y value is 5, so I go up 5. 1, 2, 3, 4, 5. So then you put your little dot there. So that's the point 2, 5. That's a solution. Now remember your quadrants. So you see how your x and y axis divides the plane into how many parts? 4. They're called quadrants. So this is quadrant 1. This is quadrant 2. You go counterclockwise. This is quadrant 3. And this is quadrant 4. This one right here. Okay? All right, let's go ahead and graph the other point. The other point was 0, 7. We're going to put it as an ordered pair, 0, 7. To plot a point, I always start at the origin. Remember the origin, I use the word origin. The origin is where the x and the y axis intersect, which means that the x coordinate is what number? 0, and the y coordinate is what number? No. At the origin. 0. 0, 0, right? Okay, so this point right here is the point 0, 0. Okay, but I do want to plot 0, 7. All right, so I start at the origin. X coordinate is 0. Do I go right, left, or stay? I stay. It's 0. All right, my y coordinate is a positive 7. To go up or down or stay? I go up how many units? 7. All right, so 1, 2, 3, 4, 5, 6, 7 right here, right? Okay, the other point. So far I've graphed how many solutions? 2. The other solution was negative 2, 9. You start at the origin. X is negative this time. So remember, x, you go right or left. You go along the x-axis. That's easy to remember. The y coordinate, you go up or down along the y-axis. So the x coordinate's negative 2. So from the origin, I go which way? Left. To the left 2 units. 1, 2. You even see the negative 2 right here, don't you? All right, so I'm hovering over here. Then the y coordinate is positive 9. So I go up 9. So negative 2, 9 is right here. So far I have how many solutions that I've graphed? 3. I've plotted 3 solutions. How many solutions do you think there are? An infinite number. So I can't keep doing that for an infinite number of times, right? But I still want to denote all those solutions. So where do you think those solutions lie? For example, I'm going to ask this. Do you think this right here is going to be a solution? No. It's not going to be a solution. Your solutions looks like they're going to end up being where? On a line. They are linear. They're all collinear. See, if I kept on going, let's say I wanted to let x be 4. If x is 4, 4 plus what is 7? 3. So I'm going to plot the point 4, 3. 4, 3. So I apply the 0.43, I go to the right 4, and then what? Up 3. So if you look at this, do you see that all these points lie on the same line? See it? So if so this point right here that I'm pointing to right here, is that going to be a solution? Yes. This point right here, is that going to be a solution? Yes. So in fact, all of your solutions are this line right here. Now don't forget to draw your arrows. Some of you always leave the arrows off and you get upset because I don't give you full credit. So draw your arrows. The arrows indicate that it keeps on going. So you're drawing a line, not a segment. If you don't put the arrows there, that's a segment. A segment has end points. All right. So all your solutions lie where? On this line. So if it kept on going, my solution would have to be here. Is this point right here a solution? No. So if you look at 3, 1, you see right here, that's not a solution. You know it's not a solution because this point is 3, 1, right? So x is 3. What's my y value? 1. So is 3 plus 1 equal to 7? No. That's why it's not a solution. That's why it's not on the graph. Any point on this line is a solution. Okay, let's look at this one. So this will be number 2. So this is number 1. So basically we're graphing linear equations. So go ahead and title this as graphing linear equations. And so this was number 1. All right, now let's look at number 2. Number 2. All right, so number 2, let's suppose we had this equation. We have y equal negative 3x plus 1. Y equals negative 3x plus 1. So the easy kind when solving a linear, and this is a linear equation, it has how many variables do you see? 2. So there are going to be how many solutions? An infinite number. Now to graph a line, you just need how many points? At least how many points? You really need 2, but we're going to use 3 because we could have made an error, right? That's why we use 3, just in case we made an error with one of the others. Because they all have to be collinear. Collinear means they lie on the same line. So we're going to do 3 points. The easy kind is where y is always by itself. So if y is by itself, everybody should get it. So I'm going to use the t-table. So one of the things you learned last semester, and you did graphing lines last semester when you took 98, one of the things you learned is to graph this using slope and intercept. You may remember that? But read the directions very carefully. The directions are going to say use a t-table, so make sure you use a t-table. So you may remember slope and intercept and all that, but that's not the way you want to, they're asking you to do this. They're asking you to do this using a t-table. So we're going to use a t-table. See, this right here is called a t-table. When y is by itself, that's the easy kind. You're going to let x be a number. And always use an integer. It helps. Don't use a decimal. Don't use a fraction. Use an integer. 0 is always the easy one to use. So if x is 0, always use 0. If x is 0, here's what I get. I'm going to substitute. I have y equal negative 3 times x. What's x? 0 plus 1. Okay? And remember, I'm trying to find out what y is, right? Y is by itself already. I have a multiplication and an addition. According to the order of operations, what do I do first? Multiplication. What's negative 3 times 0?
0.
And what's 0 plus 1?
1.
So what's my y value? 1. So I have one solution so far. It's the ordered pair 0, 1. I need how many more? 2 more, because you really need just 2, but use 3 points altogether just in case you made an error with one of the others, because they're all supposed to lie in the same line. Let's say x is, you just use any number, and you always want to use numbers that will fall within the grid that you have. So let's say x is 2. Okay, if x is 2, I get y equal negative 3 times x. What's x? 2 plus 1, right? Order of operation. Now remember, y is already by itself. You want to get y by itself. It's already by itself. The order of operation is multiplication, addition. What do I do first? Multiplication. Negative 6 plus 1 is? Not 5. Negative 5. So when x is 2, my y value is? Negative 5. All right, I need one more. If x, let's say, is... Now, when you do it by yourself, if you want to use all positive numbers and 0, that's fine. But I'm going to put in a negative in here. If x is negative 1, x is negative 1, let's say, I get y equal negative 3 times x. What's x?
Negative 1.
Plus 1. What do I do first?
Multiply.
What's negative 3 times a negative 1?
Positive 3.
And what's 3 plus 1?
4.
4. So I plot the point, negative 1, 4. So far, I've determined how many solutions? 3. And all those solutions better lie where? On the same line. And how many solutions does this equation have? An infinite number. Can you list them? No. So you have to actually graph them. All right, so let's go ahead and graph the next one. So this will be number 2. So I'm graphing y equals negative 3x plus 1. So my first ordered pair was what point? 0, 1. Notice when you indicate the ordered pairs, you put parentheses. So 0, 1, I start the origin. X is 0, I stay there. Y is what? So I go up 1. So there's one of my points right here, one of my solutions. Now, if the direction says, and it will, if the direction says label the point, let me remind you what labeling the point means. Labeling the point does not mean just putting a dot there. It means telling me where that ordered pair is. So the ordered pair is what? 0, 1. So you actually write 0, 1. That's the labeling. Okay? That's the labeling. So you say 0, 1. The other ordered pair is what? What was it? 2, negative 5, okay? So let's plot the point, 2, negative 5. So I go from the origin, I go which way?
Right.
To the right 2, and then what?
Down.
Down 5. 1, 2, 3, 4, 5. That's right here. If it says label, what else do I need to say? 2, negative 5 in parentheses. Okay? And then the other ordered pair was negative 1, 4. So I go to the left 1, and then what? Up 4. 1, 2, 3, 4. And if it says label, I got to say negative 1, 4, just like this. And then all of those 3 points better lie on the same line, right? Now, for some reason, and it's going to happen to a few of you with the worksheets, you're going to stop there and you're not going to do anything else. Well, all you've done was told me how many solutions right here? 3. When you graph a line, when you're graphing an equation, you're graphing the solutions. Does this equation have just 3 solutions? No. So you can't just stop and plot those 3 points and say you're done. You actually have to indicate it using a line because there's an infinite number of solutions. So just use your ruler and just draw a line. What else must I put though? The arrows. That's all that is. Okay? All right, we're going to do one more with this, and we'll continue on with this next class period. Let's look at this, though. Look at this. So remember, in these two problems we've done, the ordered pairs, the x coordinates and the y coordinates, were what kind of numbers? No, they weren't all whole numbers, but what's a better word to use? Integers. Your whole numbers are 1, 2, 3, 4, and so on. Your integers include the negative components. So those are integers. So integers. So all these were integers. It helps if they are integers. Yes?
So how do you know, like, what's the all real numbers?
What now?
All real numbers? Because sometimes they be the answer to the question. When they say all real numbers, what's real numbers?
A real number is any number that you've ever dealt with. Decimals, fractions, those are real numbers.
Including negatives?
Yeah.
Oh,
Yeah. Yep. There were times when I had negative $4 in the bank. That's real. That was real.
Okay,
All right. Now, the other thing you could see, and this will be the situation for the most part, because I always want to throw in some things to see if you can go further with it. What if we had this? Y equals 3/4 x minus 2. All right. Y equals 3/4 x minus 2. Notice that number 2 was easy because the coefficient of x was an integer, right? -3. And remember I said earlier that the easy problem is always when y is already by itself. So y is by itself, so that's going to be an easy problem. But it became a little bit more complicated because the coefficient of x is not an integer. It's a fraction. It's a real number. It's just not an integer. Okay? Now listen carefully as we go through this. So I'm going to use a t-table. And one of the numbers we always used for x was what number? 0. So 0 is always an easy one to use. So if I let x be 0, just like we did in number 2, this is what we did. We said y equals 3/4 times x. What is x? 0. Subtract 2. Remember, you're solving this equation. You get your y by itself. Well, y is already by itself. So I do multiplication before subtraction. 3/4 times 0 is 0. 0 minus 2 is? Not 2. -2. Okay. All right, so I'm going to plot the point. 0, -2. So let's go ahead and plot that point, 0, -2. All right, so 0, -2. It's right here. All right, now listen carefully. Don't use 1. And let's see why you would not want to use 1. If x is 1, look how complicated it becomes. If x is 1, you would say y equals 3/4 times 1 minus 2, right? And so 3/4 times 1 is 3/4. Then you would have to figure out, all right, well, what is 3/4 minus 2? All right, you could do that. 3/4 minus 2 is 1 1/4, right? Then you'd have to go to your graph and estimate where 1 1/4 is. So you see, there's a little bit of work here. So this is 1 1/4. What you want to do, though, is that when the coefficient is a fraction, you want to use numbers for x that are divisible by the denominator, 4. You want to use numbers for x that are divisible by 4. Listen carefully. Always use multiples of 4. Those are divisible by 4. So 4 and a what? -4. 8 and a what? -8. 12 and a what? -12. So those are the numbers you would use. But of all those numbers that I just listed, and there's an infinite number of those, of all those numbers that I had listed, I would use 4 and -4. So whenever you have fractions, use values for x that are divisible by the denominator. So this was a 5. You would use 0, 5, -5, or 10, -10, and so on. If this was 7, you'd use 0. Always use 0. 7, -7, or 14, -14. Denominator. So if x is 4, look how simple this is. So if x is 4, I get y equals 3/4 times 4 minus 2, right? All right, think about this right here. Just look at this for right now. And you had that in a couple of problems we did earlier. Reduce. 4 to 4 is 1. 4 to 4 is 1. 3 times 1 is 3. And what's 3 minus 2? 1. If x is -4, look what happens. I get y equals 3/4 times -4 minus 2. And reduce. 4 to 4 is 1. 4 to -4 is a -1. 3 times -1, -3. And a -2 gives me -5. A -3 and a -2 is a -5. And so I can plot the points now. So if I plot the points, I get 0, -2. I've already done that. 4, 1 is in quadrant 1. And -4, -5. So I go to the left 4 and then what? Down 5. Now if it says label, just make sure you label. So you're gonna say 4, 1, 0, -2, -4, -5, just like this. And then you just draw your line and you're done. Just draw your line and you are done. Okay? Now again, how many solutions does this equation have? Infinite number. You can't explicitly list them, so you have to graph them. So to graph a line, how many points do we need? You need at least 2, but we're going to use 3. And if the coefficient is a fraction, use numbers that are divisible by the denominator. All right. Now we can continue with this Tuesday, but for right now,